Have you ever just looked up at the night sky, at all those stars, and had this thought, in a universe this old and this mind-bogglingly vast, why is it so quiet? It's one of the deepest, most unsettling questions we can possibly ask, and it's right at the heart of the cosmic mystery we're going to explore today, the Fermi Paradox.
And it all kicked off with a ridiculously simple question. So picture this. It's 1950. The brilliant physicist Enrico Fermi is at lunch with some colleagues talking about aliens when he just casually asks, "Where is everybody?" And no, he wasn't wondering where his lunch buddies went. He was talking about extraterrestrials. And with just those three little words, he nailed this massive contradiction that has kept scientists up at night ever since.
All right, so let's really frame this problem. In one corner, you have the sheer, almost unimaginable scale of the universe. And in the other corner, you have what we've actually found out there, which is a whole lot of nothing. This massive contradiction has a name, the Great Silence. To get a feel for the scale we're talking about, let's just start with our own cosmic neighborhood, the Milky Way galaxy. We think there are somewhere between 100 and 400 billion stars right here. Now that number is so big it's basically meaningless, so try this. That's more stars than there are grains of sand on every single beach on planet Earth. Just think about that. An absolutely insane number of chances for life. And here's the thing, we now know for a fact that planets aren't some rare, special thing. Nope, they're everywhere. They're super common. Ever since the 90s, we've confirmed over 5,000 planets orbiting other stars, and all the data tells us that pretty much every star has planets. So the basic ingredients, the real estate for life, it's all over the place. But this is where it gets really juicy. Okay, let's narrow it down. Let's just look for planets in the habitable zone. You know, that perfect little sweet spot where liquid water could exist on the surface. Even with that filter, we're still looking at billions of potentially habitable worlds. Billions, just in our galaxy. So we've got billions of suns, probably trillions of planets, and billions of those are just right. So what's the punchline? After decades of searching, pointing our most powerful telescopes at the sky, listening for any little beep or boop, any sign of technology, we've found nothing. Zilch. An unnerving, cosmic, deafening silence. So how do you even begin to get a handle on a mystery this huge? Well, one of the most famous tools scientists use is something called the Drake equation. Now, it's not meant to give us a precise final answer. It's really just a fantastic way to organize our ignorance and put the mystery into a logical framework. And here it is, the Drake equation. It looks a little complex, but the idea is actually pretty straightforward. N on the left is the number we want. How many chatty alien civilizations are in our galaxy right now? And to get to N, you just multiply a whole chain of probabilities together. Things like the rate of star formation, the fraction of those with planets, how many of those develop life, and so on, all the way to how long a civilization sticks around. And this table just lays out the problem so perfectly. You see, the first few variables, the astronomy parts, like how many good planets are out there, we're getting pretty good at those. Our certainty's going up and up. But then, as you go down the list, our knowledge just falls off a cliff. How often does life arise? We have no clue. How often does it get intelligent enough to build a radio? Total guesswork. And then you get to the last one, L. How long does civilizations last before they, go extinct? That is the great unknown, and it might just be the most important variable in the entire equation. Okay, so the numbers are basically a giant shrug. That leaves us with theories. So let's play detective for a bit and run through the prime suspects, the big ideas that try to explain why nobody's calling. So the first and maybe simplest group of answers is, maybe there's nobody out there to talk to. The rare earth hypothesis suggests that, yeah, maybe slime and microbes are a dime a dozen, but the very specific long list of things that allowed for complex life here, like a big moon to stabilize our orbit and plate tectonics to regulate the climate, maybe that combination is just freakishly rare. Another idea? Maybe we're just early. The universe is still pretty young, cosmically speaking. It's possible we're simply one of the first civilizations to arrive at the cosmic party. But what if they are out there and they're just being quiet on purpose? One idea is the zoo hypothesis. It suggests that advanced civilizations know we're here, but they're intentionally not making contact. They're observing us, kind of like we observe animals in a nature preserve. But there's a much, much creepier version, the dark forest hypothesis. This theory imagines the universe as a dark forest full of silent hunters. In a forest like that, the smartest thing you can do is not make a sound. Shouting, "Hey, I'm over here," might attract a predator. So in that universe, every civilization is hiding, and silence is the ultimate survival strategy.
And that brings us to what might be the most powerful and, frankly, the most terrifying explanation for the silence. It's an idea that has huge implications for us, for humanity's future. It's called the Great Filter.
So the Great Filter is some kind of massive evolutionary wall. It's a step in the long journey from simple life to a starfaring civilization that is so incredibly hard to get past that almost nobody ever makes it. And right here, this is the billion-dollar question. Where is the filter? Is it behind us in our past, or is it still waiting for us up ahead? Now, if the filter is behind us, if getting life started in the first place or evolving intelligence was the unbelievably hard part, then that's fantastic news for us. It means we're rare, we're special, we won the cosmic lottery. But if the silence is because the filter is ahead of us, well, that is absolutely terrible news. It suggests that something almost always destroys civilizations like ours before they get any further.
So what could a future filter even look like? Well, unfortunately, you don't have to look much further than our own headlines. These are the existential threats we worry about right now. Self-destruction from nuclear war, and artificial intelligence we can't control, climate change that spirals out of control, a lab-created pandemic. The Great Silence in this case could be a cosmic warning sign that no one ever manages to solve these kinds of problems.
So let's bring all this back down to Earth. Why should you care about any of this? Because, when you get right down to it, the Fermi Paradox isn't just about aliens. It's really a mirror reflecting our own potential, our own fragility, and our own future.
This all leads to a really strange, totally counterintuitive conclusion. You'd think that finding little microbes on Mars would be the best news ever, right? A monumental discovery. But from the Great Filter perspective, it might actually be the worst news humanity could possibly receive. Why? Well, think it through. If simple life is common, if it pops up easily all over the place, then that means the origin of life probably wasn't the Great Filter, which makes it much, much more likely that the real, civilization-ending filter is something further down the road, something that's still waiting for us. In a weird way, an empty, lifeless universe is a hopeful sign for our future.
So you see, this is so much more than a fun science puzzle. It really forces us to wrestle with the biggest questions there are. What does it actually mean to be intelligent? What is the ultimate point of all our technology? And what is our responsibility as a tiny species on a small rock that is suddenly aware of the entire cosmos? So I want to leave you with this one last haunting thought. When we look out at the silent stars, what are we actually looking at? Are we looking at a galactic tombstone, the quiet evidence that no civilization ever makes it? Or are we looking at a cradle, an empty universe just waiting for the first voices to finally break the silence? Voices that could, and maybe should, be our own. The answer to that question might just be the most important thing we ever figure out.